Hello everyone. In this lecture, I am going to prove if a sequence is convergence sequence, then the subsequence is also convergence. If the sequence converges to a limit L, the subsequence is also converges to same limit L. If the sequence Sn converges to a limit L, then the subsequence Sn converges to same limit. This is the theorem we are going to prove. In this theorem, sequence Sn is convergence sequence. I am assuming as sequence Sn is a convergence sequence, which is converges to a number, a real number S. The sequence Sn converges to a real number S. Then, and also we assume as subsequence Snk be a subsequence of a sequence Sn. Already we know that subsequence of a sequence Sn. Suppose Snk is a subsequence of a sequence Sn. It's satisfying some condition. Nk is the increasing sequence of strictly increasing sequence of natural numbers. Then Snk is called as a subsequence of a sequence Sn. Now here we assume as Snk is a subsequence of a sequence Sn. Now we are going to prove that the subsequence Snk converges to a limit S. This is our main aim to proving this theorem. Already given that a sequence Sn is converges to S. By definition of convergence of a sequence, already we know this. For each epsilon greater than 0, there exists a number capital N such that n greater than capital N implies mod Sn minus S less than epsilon. This is the condition. This is the definition of convergence of a sequence. Here S is a limit of a sequence. The sequence Sn converges to S. Then for each epsilon greater than 0, there exists a number capital N. When n greater than capital N, then the difference of Sn and S is always less than epsilon. Yes. Since already Snk is a subsequence of a sequence Sn, then whenever it is a subsequence, already I explained Snk subsequence means Nk is a strictly increasing sequence of natural numbers. It is a strictly increasing sequence of natural numbers. Nk is a strictly increasing of sequence of natural number means n1 less than n2 less than n3 less than and so on less than nk plus 1 less than nk plus 1 for all k belongs to n. K is a natural number. This is the first number, second number, third number. That means n1, n2, n3, they all are the strictly increasing sequence of natural numbers. Means in general nk is less than nk plus 1 for k belongs to natural number. So you observe this condition, nk is less than nk plus 1 for all k belongs to natural number. Now for using of this condition, now what we are going to prove? The subsequence Snk converges to same limit S. That means we are going to prove that Snk, the subsequence Snk converges to same limit S means less than epsilon. When this condition is holds, this nk greater than some number n. Now we are going to prove that nk greater than n implies mod Snk minus S less than epsilon. This condition is holds, so we are going to prove. For this, first we are going to prove nk greater than n. First I am saying that nk, the numbers of strictly increasing sequence of natural numbers nk is always bigger than certain number n. After that, the sequence Snk is said to be converges to same limit S. For that, I am going to prove nk greater than or equal to k. So the nk is must be either greater than or equal to k for every k belongs to n. This can prove by using induction method. అంటే దీన్ని చెప్పడం కోసం nk greater than n అని చెప్పడానికంటే ముందుగా nk greater than or equal to k for every k is a natural number. దీన్ని ప్రూఫ్ చేస్తున్నాను by induction method ప్రకారంగా. What is induction method? What is the induction method? This is for k is equal to 1. I am taking k is equal to 1. Induction method, you know, suppose the result is true for 1, we assume as result is true for k, then we have to prove that the result is true for k plus 1. n ఈక్వల్ టు 1కు అజ్యూమ్ చేసుకుంటాం, n ఈక్వల్ టు 1కు ట్రూ అయితే n ఈక్వల్ టు kకు అజ్యూమ్ చేసుకుంటాము, తర్వాత k ప్లస్ 1కు ప్రూవ్ చేస్తాం. ఇక్కడ k ప్లేస్లో తీసుకుంటున్నాను, k ఈజ్ ఈక్వల్ టు 1 తీసుకున్నట్లయితే అప్పుడు ఏమవుతుంది, ఇందులో n1 గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు 1. దిస్ ఈజ్ ట్రూ because of the sequence nk is a strictly increasing sequence of natural numbers. Because of natural numbers n1, n2, n3 are the strictly increasing sequence of natural numbers starting with 1. For that n1, all the members of the sequence n1, n2, n3, all the members of the sequence is must be greater than or equal to 1. I think అర్థమైంది అనుకుంటాను. ఇక్కడ k is equal to 1 పెడితే n1 greater than or equal to 1 వస్తుంది. ఇది ట్రూ అవుతుంది. ఎందుకు ట్రూ అని చెప్తున్నానంటే ఇక్కడ ఉన్నటువంటి n1, n2, n3 ఆర్ ది సీక్వెన్స్ ఆఫ్ స్ట్రిక్ట్లీ ఇంక్రీజింగ్ సీక్వెన్స్ ఆఫ్ న్యాచురల్ నెంబర్స్. ఇవి అంటే లైక్ దట్ 1 లెస్ దెన్ 2 లెస్ దెన్ 3 లెస్ దెన్ లైక్ దట్. అంటే స్టార్టింగ్ నెంబర్ ఏమై ఉండాలి, మస్ట్గా 1 ఆర్ అబోవ్ అయి ఉండాలి. ఫర్ దట్ n1 గ్రేటర్ దెన్ ఆర్ ఈక్వల్ టు 1. సో దిస్ ఈజ్ ట్రూ ఫర్ k ఈజ్ ఈక్వల్ టు 1. నౌ assume that nk greater than or equal to k. nk greater than or equal to k. Assume that the sequence is this result is true for k, nk greater than or equal to k. Then we are going to prove that nk plus 1 is greater than or equal to k plus 1 by induction method. I am going to prove this result. nk plus 1 is greater than or equal to k plus 1. For that from equation 2, from above equation, nk plus 1 is greater than nk. Yes, from equation 2, nk plus 1 is greater than nk means nk is a strictly increasing sequence of natural numbers. The number nk is smaller than next number k plus 1th term. For that, this condition is true for k is any natural number. So now I am taking this is nk plus 1 is greater than or equal to nk plus 1. nk plus 1 this term is greater than or equal to nk plus 1. అంటే kth టర్మ్ ప్లస్ 1 యాడ్ చేస్తే అది ఏమవుతుందంటే గ్రేటర్ దాన్ ఈక్వల్. ఇది ఒక రూల్. ఈ రూల్ ఏంటిది అంటే దిస్ ప్రాపర్టీ ఈజ్ నోన్ యాజ్ ఏ న్యాచురల్ నెంబర్స్ ప్రాపర్టీ. సపోజ్ m and n are two natural numbers such that m greater than n. Out of these two natural numbers m is bigger than n, then m greater than or equal to n plus 1. m greater than n ఉన్నప్పుడు m is either equal to or greater than n plus 1. ఇది కండిషన్. దిస్ ప్రాపర్టీ ఈజ్ కాల్డ్ యాజ్ ఏ ప్రాపర్టీ ఆఫ్ న్యాచురల్ నెంబర్స్. అంటే m n రెండు నెంబర్స్ తీసుకుంటే m ఈజ్ బిగ్గర్ దెన్ n, దెన్ ఇఫ్ యాడింగ్ రైట్ హ్యాండ్ సైడ్ ప్లస్ 1, దెన్ దట్ నెంబర్ m either equal to n plus 1 or must be greater than n plus 1. For example, I am taking two numbers. Look here, 5 and 3 are the two numbers in m is equal to 5, n is equal to 3. Right? So 5 greater than 3. Then what happens here? 5 is also greater than or equal to 3 plus 1. Actually it is strictly 5 greater than 3 plus 1 means 4. 5 is strictly greater than 4. So this condition is holds. Suppose I am taking 3 and 4 natural numbers. 4 is greater than 3. Then m is equal to 4, n is equal to 3. Then what is the m greater than n plus 1? Here equality condition is holds. So now what is the property? Here I can use it. M and n are two natural numbers. M less greater than n, then m is greater than or equal to n plus 1. You observe here nk plus 1 is greater than or equal to nk plus 1. Here you observe nk plus 1 is greater than, strictly greater than nk. These two are the natural numbers. Nk plus 1 and nk are the two natural numbers. Then this property nk plus 1 is greater than or equal to nk plus 1, next number, n plus 1th number. That means nk plus 1 is greater than or equal to nk plus 1, which is greater than or equal to k plus 1. మరి ఇది ఎలా వచ్చింది? Look here. Already from equation 3, here from equation 3, nk greater than or equal to k. Adding on both sides, nk plus 1 greater than or equal to k plus 1. Not this is k plus 1th term. nk plus 1, kth term plus 1 is always greater than or equal to k plus 1. So here already nk plus 1 greater than or equal to nk plus 1, which is greater than or equal to already here k plus 1. So that nk plus 1 is always greater than or equal to k plus 1. So n ఉన్న చోటల్లో ఏముంది ఇక్కడ k plus 1. In general by the principle of mathematical induction, nk greater than or equal to k. Here see generally k plus 1 place లో ఇక్కడ రెండు సేమ్ ఉన్నాయి కాబట్టి I can write nk greater than or equal to k for every k belongs to n. So this is the principle of mathematical induction. In general this can be written as nk greater than or equal to k for every k belongs to n. For k greater than n, actually this start for k greater than n, k is bigger than n, we have, for k greater than n, we have, ఏమొచ్చింది మనకి ఇక్కడ nk greater than or equal to k. So I'm taking for k greater than n. Already we have nk greater than or equal to k, nk greater than or equal to k, then k is bigger than n. So this implies nk is greater than n. Nk is also greater than n. So k is any natural number. So nk greater than n, yes, మనం ఏమైతే కావాలనుకున్నామో అది వచ్చేసింది. nk greater than n, for each epsilon greater than 0, there exists a number capital N such that this number nk, n suffix k is a natural number, nk greater than capital N implies, according to our definition here, Sn, if n greater than capital N, I can write Sn. If nk greater than capital N, I can write Snk minus S less than epsilon. Yes, same, whenever this condition nk is greater than capital N, then this condition is holds by equation 1. From equation 1, what is the condition? For k greater than 1, condition is for k greater than n, for k greater than n, this condition, small n greater than capital N, then mod Sn minus S less than epsilon. In case here, instead of n, we have nk greater than capital N, but I am writing modulus of Snk, sequence, subsequence Snk minus S is less than epsilon. So mod Snk minus S less than epsilon. This means Snk is a subsequence which is converges to S. Subsequence Snk converges to limit S. S is the limit of the sequence Sn. Therefore, every subsequence of a sequence converges to same limit of a sequence. Now, here I am giving some example for above theorem. What says above theorem? A sequence converges to a limit L. The subsequence is also converges to same limit L. Suppose here Sn is equal to 1 by n. Actually, we know that the sequence is converges, whose limit is 0. So the limit of a sequence Sn is 0. Therefore, subsequential limits also 0. We are going to prove this one. Now, what is the subsequences of sequence even? Suppose S2n is equal to one of the subsequences even natural numbers, 1 by 2, 1 by 4, 1 by 6, and so on, 1 by 2n. So S2n is even natural numbers. So replacing n by 2n, we get 1 by 2n. That means 1 by 2, 1 by 4, 1 by 6, 1 by 8, like that. Then what is the limit of this subsequence S2n? Limit n tends to infinity, 1 by 2n. 1 by infinity means 0. This is 0. One of the subsequence limit is 0. Suppose I am taking another subsequence S2n minus 1. S2n means odd numbers of the sequence. Odd numbers means S3, S1, S3, S5, S6. S1 means what? 1 by 1. S3, 1 by 3. S4, 1 by 5, like that. 1 by 2n minus 1. So here nk is equal to, here I am taking nk is equal to 2k minus 1. Odd numbers. Here nk is equal to 2k. So even, here odd. So this is one subsequence. Even numbers of the sequence is S2nk, Snk. This is Snk is denoted by S2n. Odd numbers of the sequences Snk, it is denoted by S2n minus 1. This is like that. Limit of this sequence is also 0. Because of 1 by, limit n tends to infinity, 1 by 2n minus 1, this becomes 0. So S2n, S2n minus 1. The subsequential limits are equal. This is 0, this is 0. These two subsequences are having same limit 0. And limit of the sequence Sn is also equal to 0. So subsequential limits is 0. Limit of a sequence is 0. Therefore, if a sequence is converges to limit 0, the subsequences also converges to same limit 0. This is the example for above theorem statement. Hence, subsequence of a sequence Sn converges to same limit of a sequence Sn. The limits of the subsequences is called as subsequential limits. Subsequential limits. The limits of a sequence, here subsequence S2n and S2n minus 1. These two are the subsequences. The limits of these subsequences is 0. So these limits is called as a subsequential limits of a sequence Sn. So subsequential limits of a sequence Sn, or these two are the limits. Now I am giving the divergence criteria for sequence. Divergence criteria for a sequence. A sequence Sn of real numbers is a diverges if either of the following condition is holds. A sequence Sn of real numbers is a divergent sequence. If a sequence is a divergent sequence, then following conditions, one of them is satisfied. One of them condition is satisfied, then the sequence is a divergent sequence. At least one of them. If this out of 3, one condition is satisfied, then we say that the sequence is a divergent sequence. This is called as a divergence criteria for a sequence. Means Sn has two subsequences, Snk and Snl, that converging to two different limits. This sequence having two subsequences Snk and Snl, out of these two subsequences whose limits are different. These two limits are finite, they are converging to different limits. Suppose Snk limit is L1, Snl limit is L2, L1 is not equal to L2, then we say that the sequence is divergent. That means subsequential limits are different, both are converging but limits are different, then we say that sequence is divergent sequence. So Sn has a subsequence that is divergent. Sn has a subsequence that is divergent. In case the subsequence of Sn ku oka subsequence untundi, aa subsequence ganaka divergent aithe original sequence kuda divergent avutundi. In case the sequence Sn is unbounded, in this case also we say that the original sequence is divergent sequence. Sequence is unbounded, the original sequence is divergent sequence. This is the criteria for divergence of a sequence. That first condition is the two subsequences of a sequence, they are having two different limits, then only we say that sequence is divergent. అంటే ఒక సీక్వెన్స్కి రెండు సబ్సీక్వెన్స్లు తీసుకుంటే దాని యొక్క లిమిట్స్ రెండు కూడా డిఫరెంట్ వస్తే అప్పుడు ఆ సీక్వెన్స్ డైవర్జెంట్ సీక్వెన్స్. ఆ సీక్వెన్సీ యొక్క సబ్సీక్వెన్స్ డైవర్జెంట్ అయితే ఆటోమేటికల్గా సీక్వెన్స్ కూడా డైవర్జెంట్ అవుతుంది. ఒకవేళ సీక్వెన్స్ అన్బౌండెడ్ సీక్వెన్స్ అయితే, సీక్వెన్స్ కనుక అన్బౌండెడ్ సీక్వెన్స్ అయితే అప్పుడు కూడా ఆ సీక్వెన్స్ని ఏమంటామంటే డైవర్జెంట్ సీక్వెన్స్ అంటాం. దీనికి కొన్ని ఎగ్జాంపుల్స్ ఇక్కడ ఇవ్వడం జరిగింది. నౌ ఐఎమ్ గివింగ్ సమ్ ఎగ్జాంపుల్స్ ఆఫ్ ఏ అబౌవ్ డైవర్జెన్స్ క్రైటీరియా. సపోజ్ Sn is equal to -1 to the power of n. We know that this is the range of the sequence is -1 and +1. Here -1 + 1 -1 + 1 -1 + 1. So one of the subsequences of a sequence is 1 1 1 1. The limit of the sequence is 1. Even terms S1, S2, S4, S6. Therefore 1 1 1 1 is a subsequent like this. One of the subsequences even terms of the subsequence. Another one is odd terms of the subsequence. 1 1 1 -1 1 1. So even terms of subsequence limits is +1. Odd terms of the subsequence limit is -1. So these two are the subsequences whose limits are different. This is converging to 1, this is converging to -1. Limits are different, therefore this sequence is divergent sequence. Yes, in previous also we proved that the sequence -1 to the power of n is a divergent in different manner. In the chapter we can find subsequences limits. If these two subsequences limits are different, the original sequence is divergent sequence. Suppose I am taking Sn is equal to n. I am giving example for second one. S2n is equal to 2, 4, 6 and so on to n. S2n -1 odd terms of the sequence is this one. What is the limit of the sequence? 2n కి లిమిట్ అప్లై చేస్తే ఏమవుతుంది? 2 × ∞. దీనికి లిమిట్ అప్లై చేస్తే 2n -1. లిమిట్ n tends to S2n -1 is equal to all terms of the sequence. This is infinity. So this is +∞, this is also +∞. Is it equal? This is divergent sequence. Not converging. This is diverging to +∞, diverging to +∞. These two are diverges. Therefore the given sequence is also divergent sequence. So the subsequence Sn has a subsequence which is divergent. Sn has a subsequence. This having a subsequence, దీనికి ఒక సబ్సీక్వెన్స్ ఉంది. ఆ సబ్సీక్వెన్స్ ఇది డైవర్జెంట్ సీక్వెన్స్ కాబట్టి గివెన్ సీక్వెన్స్ కూడా ఏమవుతుంది? డైవర్జెంట్ సీక్వెన్స్ అవుతుంది. సో దీస్ ఆర్ ది ఎగ్జాంపుల్స్ ఫర్ డైవర్జెన్స్ క్రైటీరియా ఆఫ్ ఏ సీక్వెన్స్ ఆఫ్ real numbers. Now I am giving limit and limit point clarification. What is limit? What is limit point? Here limit of a sequence is a limit point of a sequence. Now theorem is limit of a sequence. Suppose a sequence has a limit is L. that L must be a limit point of a sequence. So limit of a sequence is a limit point of a sequence, but limit point of a sequence need not be a limit of a sequence. Students ఇక్కడ కన్ఫ్యూజ్ కావద్దు. లిమిట్ ఆఫ్ ఏ సీక్వెన్స్ ఈజ్ డిఫరెంట్ ఫ్రమ్ లిమిట్ ఆఫ్ పాయింట్ ఆఫ్ ఏ సీక్వెన్స్. Now what is a limit? A sequence Sn converges to S, that S is called as a limit of a sequence, but not L is limit point in always. L is not a limit point in general, right? Suppose Sn be a sequence such that limit n tends to Sn is equal to S, means the limit of the sequence is L, and the sequence is converges to L. The limit of a sequence is L. Now I am going to prove that L is also limit point of a sequence. L is also limit point of a sequence. For each epsilon greater than 0, now definition of convergence, there exists a number capital N such that n greater than capital N. This is the convergence definition. Now removing this modulus, we know that the property mod x less than or equal to some mod x less than c, some particular number, then what we write? Minus c less than x less than plus c. Same criteria I can apply here. For n greater than capital N, the small n is bigger than certain number capital N. N is a certain number, not natural number. Adding L on both sides, L minus epsilon less than Sn minus L plus L cancel here, less than L plus epsilon n greater than n. So L minus epsilon less than Sn less than L plus epsilon for n greater than capital N. That means Sn is belongs to an open interval L minus epsilon to L plus epsilon. Epsilon is a small positive quantity. So the number Sn belongs to L minus epsilon comma L plus epsilon n greater than capital N. That means in case you take n is equal to 5, n is equal to 5, so then small n becomes what? Small n is equal to 6, 7, 8 like that. That means what? That means what? S6, S7, S8. These are all the terms belongs to L minus epsilon, L plus epsilon. So all the terms in this interval except finite number of terms. So that L minus epsilon, L plus epsilon containing infinitely many Sns. Only finite terms, కొన్ని terms మాత్రం మిస్ అయిపోయినాయి. లేదు, if you take n is equal to 100 తీసుకున్నాం అనుకో, ఎక్కడ స్టార్ట్ అవుతుంది? S100, S101, S102, 103. అంటే ఎన్ని మిస్ అయినాయి? ఫస్ట్ 100 టర్మ్ మిస్ అయిపోయినాయి. అంటే దట్ మీన్స్ in this interval containing all the terms except finite number of terms. ఈ ఇంటర్వెల్లో అన్ని టర్మ్స్ ఉన్నాయి, కానీ కొన్ని పరిమిత టర్మ్స్ లేవు. కాబట్టి అప్పుడు ఆ ఎల్ ఏమంటామంటే ఎల్ ఈజ్ కాల్డ్ యాజ్ ఏ లిమిట్ పాయింట్ ఆఫ్ ఏ సీక్వెన్స్ Sn. By the definition of limit point, all the members of the sequence contains this interval. All the members of the sequence contains this interval except finite number of terms. Therefore, L is called as a limit point of a sequence Sn. Now, what is the converse of this theorem is not true, need not be true. Now, this is the remark for this. The converse of the above theorem need not be true. That means what? If L is a limit point, but that L need not be a limit of a sequence. Every limit point of a sequence need not be a limit of a sequence. Is clear? Limit point అనేది Sn అనే సీక్వెన్స్కి లిమిట్ పాయింట్ అయితే ఎవరి లిమిట్ పాయింట్ అనేది లిమిట్ కాదు, కానీ ఎవరి లిమిట్ ఈజ్ ఏ లిమిట్ పాయింట్ ఆఫ్ ఏ సీక్వెన్స్. సింపుల్ ఎగ్జాంపుల్ ఒకటి ఇస్తున్నాం. Sn ఈజ్ ఈక్వల్ టు -1 to the power of n. ఇది కన్వర్జెన్స్ సీక్వెన్స్ కాదు, ఇది డైవర్జెన్స్ సీక్వెన్స్. వాట్ ఆర్ ద లిమిట్స్ ఆఫ్ ది సీక్వెన్స్? -1 and +1. సో ఎవ్రీ నైబర్హుడ్ ఆఫ్ 1కు నైబర్హుడ్ కన్స్ట్రక్ట్ చేసినట్లయితే 1కు నైబర్హుడ్ ఏమైతుంది? 1 minus epsilon, 1 plus epsilon. 1 minus epsilon, 1 plus epsilon. So the neighborhood of 1 containing all the even terms of the sequences. Yes, what is the even terms of the sequence? S to n is equal to what? 1, 1, 1. Even terms of the sequence. So this 1 is belongs to this interval. 1 minus epsilon, 1 plus epsilon లో ఈ 1 ఉంటుంది. So that, and hence 1 is the limit point. 1 is the limit point. Similarly, -1కు neighborhood construct చేస్తే every neighborhood of -1 containing all the odd terms of the sequence. ఇక్కడేమో even terms of the sequence ఉంటుంది. Every neighborhood of -1 contains all odd terms of the sequence. And hence -1 is also limit point of a sequence Sn. అంటే ఇక్కడ 1కు నైబర్హుడ్ కన్స్ట్రక్ట్ చేసినప్పుడు ఏ టర్మ్స్ ఉంటాయి? ఈవెన్ టర్మ్స్ ఆఫ్ ద సీక్వెన్స్. ఈవెన్ టర్మ్స్ ఆఫ్ ద సీక్వెన్స్ 1 ఉంటుంది. -1కు నైబర్హుడ్ కన్స్ట్రక్ట్ చేసినప్పుడు ఆడ్ టర్మ్స్ ఆఫ్ సీక్వెన్స్ ఉంటుంది. కాబట్టి -1 + 1 రెండు లిమిట్స్ అవుతాయి. -1 + 1 రెండు కూడా లిమిట్ పాయింట్స్ అవుతాయి. అకార్డింగ్ టు డెఫినేషన్ ఆఫ్ లిమిట్ పాయింట్, -1 and +1 బోత్ ఆర్ ది లిమిట్ పాయింట్స్, బట్ నాట్ లిమిట్స్. ఇవి రెండు లిమిట్స్ కావు. So, but Sn is not converges, but Sn is a divergence sequence, not a convergence sequence. So, neither 1 and -1 are limits of sequence Sn. ఈ రెండు 1 - 1 లిమిట్స్ కావు. 1 - 1 1 minus 1, neither 1 and nor minus 1 are లిమిట్స్ ఆఫ్ ఏ సీక్వెన్స్ ఎస్ఎన్. ఇవి లిమిట్ పాయింట్స్ అవుతాయి కానీ ఇవి లిమిట్స్ కావు సీక్వెన్స్కి. ఒకవేళ ఇవి లిమిట్స్ అయితే అవి ఏమై ఉండాలి, ఇది కన్వర్జెన్స్ సీక్వెన్స్ కాబట్టి ఈక్వల్ ఉండాలి, కానీ కావు. కాబట్టి ఇది ఈ 1 and minus 1 ఆర్ నాట్ ఏ లిమిట్స్, బట్ 1 and minus 1 ఆర్ ది లిమిట్ పాయింట్స్ అవుతున్నాయి. వన్ థింగ్, every constant sequence is convergent. Every constant sequence is convergent. See, in Sn is equal to, I am taking constant k, means S1 first term, S1, S2, S3, all the terms are, S1 is k, S2 is k, S3 is also, all the terms should be k. So limit of the sequence is Sn is equal to k. K is a finite number, so Sn converges to k. So every constant sequence is convergent. So this important statement, every constant sequence is convergent. In series this is not convergent, whereas in series not convergent, but sequence is, every constant sequence is convergent. Right, if a sequence Sn is unbounded above, if a sequence is unbounded above means not bounded above, then it has a sequence with the limit is plus infinity. If a sequence ganaka unbounded above anta, unbounded above means not bounded above, we cannot find the maximum value కనుక్కోలేని ఆ సీక్వెన్స్ కనుక ఉన్నట్లయితే దానికి లిమిట్ ఏమవుతుందంటే ద లిమిట్ ఆఫ్ ద సబ్ సీక్వెన్స్, అట్లాంటి సీక్వెన్స్ యొక్క సబ్ సీక్వెన్స్ లిమిట్ ప్లస్ ఇన్ఫినిటీ. అన్బౌండెడ్ ఎబో అయితే, అన్బౌండెడ్ ఎబో అంటే బౌండెడ్ ఎబో కాదు అనమాట. ఇట్ గోస్ ఆన్ ప్లే 1 2 3 4 5 లైక్ దట్, ఇన్ఫినిటీ గోస్ ఆన్. సో దట్ హూజ్ సబ్ సీక్వెన్సెస్ లిమిట్ ఈజ్ ప్లస్ ఇన్ఫినిటీ. ఇన్ కేస్ ద సీక్వెన్స్ ఈజ్ అన్బౌండెడ్ బిలో కనుక అయితే, అంటే వీ కెనాట్ ఫైండ్ ఇన్ఫిమమ్ వాల్యూ కనుక మనం కనుక్కోలేకపోయినట్లయితే, ఇన్ దిస్ కేస్ ద సబ్సీక్వెన్షియల్ లిమిట్ ఈజ్ మైనస్ ఇన్ఫినిటీ. ప్లీజ్ అండర్స్టాండ్, అన్బౌండెడ్ బిలో అయినట్లయితేనేమో సబ్సీక్వెన్షియల్ లిమిట్స్ మైనస్ ఇన్ఫినిటీ అవుతుంది, అన్బౌండెడ్ ఎబో అయినట్లయితేనేమో ఆ సీక్వెన్స్ యొక్క సబ్సీక్వెన్స్ లిమిట్ ప్లస్ ఇన్ఫినిటీ అవుతుంది. ఐఎమ్ గివింగ్ స్మాల్ ఎగ్జాంపుల్ ఫర్ క్లారిఫికేషన్. Suppose Sn is equal to n square into minus 1 power n, n is belongs to capital N. Here, what is the subsequence, what is the sequence of the members of this S1, S2, S3 like that? Put n is equal to 1 here, 1 square into minus 1 power n, minus 1. Second term 4, third term minus 9, fourth term 16, fifth term minus 25 and so on. Here I am dividing two subsequences. These are one subsequence, odd terms. These are what? Even terms. So let the subsequence Snk is equal to minus 1, minus 9, minus 25 like that. That means what? S1, S3, S5, S7 like that. So it is unbounded below sequence because of starting in a real line, it is 0, starting with minus 1, minus 2, minus 3 like that. It goes to minus infinity. So it is unbounded below subsequence. It is unbounded below subsequence. So whose limit is must be minus infinity. Now I am taking 4, 16 like this. So now I am taking another sequence is limit n tends to infinity. This is equal to, another sequence is what? 4, 16 like that. Sequence is another subsequence 4, 16 like that. It is 4, 16. It is increasing unbounded increasing sequence. So that unbounded increasing sequence